Hello students, welcome to Lucky Learning. Here in this video, I am going to discuss the inter-processor communication in the multiprocessor systems and synchronization. The various processors in a multiprocessor system must be provided with a facility for communicating with each other. Means one processor need to communicate with another processor. That facility is there in the multiprocessor system. The communication path can be established through a portion of memory or a common input-output channels. The primary use of the common memory is to act as a message center, which is similar to mailbox, where each processor can leave messages for other processors in the message center and pick up messages that are intended for that particular processor. The sending processor is going to structures a request or a message, a procedure, and places it in the memory mailbox. And there should be a status bits residing in the common memory, and the receiving processor need to check that status bits and in the mailbox periodically. Is that is that message is intended to that processor or not? It has to check repeatedly. The response time of this processor can be time consuming because it has to check and then receive the message. It is a time consuming because it is taking some time to check the status conditions. A more efficient processor is for the sending processor to alert it. Suppose one processor P1 is sending message to another processor P2, then P1 has to alert P2, stating that the whatever the message it wants to send, that is available in the common shared memory mailbox, so that other processor can accept the data from the access data or message from the common shared memory. It is to alert another processor by means of an interrupt signal. This one I can show you pictorially. Here we have a shared memory, that is a communication area, and this is a sending processor. The sending processor has to send a message to another processor, and that will be placed into the shared memory. That message is placed into the shared memory, and also it has to mark the uh, message status bits, and it also give an information that message is intended to which processors. There will be multiple receiving processors. Whenever receiving processor will check the status bits, is going to receive the message if it is intended for that particular processor. And we know that this is a time consuming process. To avoid that, what is required? A sending processor has to send a message into the common shared memory in the message mailbox, and it has to mark the status bits, and it has to send it has to say that message belongs to which receivers. And after that, a sending processor has to execute an instruction. That instruction is going to interrupt the receiving processor. Because there are many processors, among the many processors, the sending processor is going to send that message to which receiving processor. It has to send an interrupt signal to that receiving processor. Once it has seen that receiving processor interrupt signal, then it has to check the status bits, and it will check is that message belonging to that particular receiver. Then it is going to read the message. This is how the processors are going to communicate with the common shared memory. Here, the interprocessor communication we will discuss with respect to tightly coupled systems and loosely coupled system separately. In tightly coupled system, the tightly coupled system is going to make use of shared memory. In addition to shared memory, a multi-processor system may have other shared resources like magnetic disk and storage units. And to prevent conflicting use of shared resources, means multiple processors are going to access the shared resources simultaneously. There may be possibility of a conflicts. To prevent conflicting use of shared resources by several processors, there must be a provision for assigning resources to the processors. Actually, assigning resources to the processors is done by whom? Done by an operating system. And there are three organizations that have been used in the design of operating system for multiprocessors. The three designs are the master slave configuration, separate operating system, and distributed operating system. In the case of master slave mode, one processor will act as a master and always that executes the operating system functions, and the remaining processors are going to execute some other programs. In the separate operating system organization, each processor can execute the operating system routines whatever it needs. This organization is more suitable in the case of loosely coupled system because each processor is going to execute the operating system routines which it needs. When in the case of distributed operating system organization, the operating system routines are distributed among the available processors. There may be multiple routines in the operating system. Each routine may be assigned to some different processors. It is distributed. However, each particular operating system function is assigned to only one processor at a time. It is also referred to as floating operating system. It is also referred to as floating operating system. And when it comes to the loosely coupled system, in the loosely coupled system, each processor have its own local private memory. It means there is no shared memory. There is no shared memory for passing information. The communication between the processors is by means of message passing through IO channels. How processors are going to communicate? By means of messages. How this is through IO channels. The communication is initiated by one processor by calling some procedure that resides in the memory of the processor with which it wishes to communicate. The communication efficiency of the interprocessor network depends on the communication routing protocol, processor speed, data link speed, and the topology of the network. Now, when it comes to the interprocessor synchronization, the instruction set of a multiprocessor contains some basic instructions which are used to implement communication as well as synchronization between the cooperating processors. Means the two processors, if they wanted to communicate between them, it requires to have some synchronization. To implement this synchronization, that multiprocessors contains some basic instructions that are used to implement the communication as well as synchronization between the cooperating processors. Communication, it is meaning that exchange of data between the different processors. When it comes to the synchronization, it is a special case where the data used to communicate between the processors is a control information. The synchronization is needed to enforce the correct sequence of processes and to ensure mutually exclusive access. What does it mean, mutually exclusive access? When one processor is accessing, the other processor has to wait for accessing the resources and to the shared writable data. Now, this is a bit more related to operating system. We call it is a mutual exclusion with semaphore. What is a mutual exclusion? One processor to exclude or lock out access to shared resources by other processors. A processor has to lock the access by other process when it is in the critical section. Now, what is a critical section? Critical section is a program sequence that once begin must complete execution before another processor access the same shared resources. Now, what is a semaphore? A semaphore is called a binary variable and it is software controlled flag. It is just like a flag that is stored in the memory that all processors can be accessed. Means that flag is stored into the common shared memory which can be accessed by all the processors. And it will be one, a processor is executing a critical section, that not available to other process. Means when semaphore is 1, it is a meaning that some processor is already executing the critical section, and that critical section is not available to other process. When it is 0, it is meaning that it is available to any requesting process. Means when semaphore bit is 0, it means that it is available to process and no other process are executing the critical section. Here you can understand this point with respect to a diagram. Here we have a memory, and in the memory semaphore is set to 0, and it is going to be test and set hardware lock to ensure mutual exclusion. A processor 1 has to see what is semaphore value. It has seen that semaphore value is 0. It is meaning that it is available for the processor 1, so that processor 1 enters into the critical section and makes this semaphore bit to 1. It makes this semaphore bit to 1. And next time, whenever the semaphore bit is 1, it is not allowed to enter the critical section. Means any other processor, it sees the semaphore bit is 1, that processor is not going to enter into the critical section. Means other processors has to wait for that. Now, let us say processor 2 is going to test and set the semaphore value for the mutual exclusion. What processor 2 sees the semaphore value is 1. So that processor 2 is not allowed to enter into the critical section. So that processor 2 is going to wait for the processor 1 to complete its execution. So that processor 2 is rejected. Here you can understand a semaphore can be initialized by means of a test and set instruction in conjunction with hardware lock mechanism. The instruction test and set lock instructions TSL SEM will be executed as an indivisible operation. So what is test semaphore? It is going to read from the memory that semaphore value into some register. So check the R value. If the R value is 1, it means that another processor is already executing the critical section, and whatever the processor is trying to enter into the critical section, that does not access the shared memory. And set semaphore, it means semaphore value in the common shared memory is set to 1, so that it is not allowing other processors to enter into the critical section. And when other processors can enter into the critical section if R equal to 0, means whenever it tests the semaphore value by reading into a register, if R equal to 0, it is available for access, and set the semaphore to 1 and access it. So why it is to set the semaphore to 1? So it will not allow other processors to access the critical section. These are being done while hardware lock, so that other processors cannot test and set while current processor is being executing these instructions. This is based on the value of R, that R is read from the memory, the value of semaphore. And finally, the last instruction in the program must clear the semaphore. Must clear the semaphore means the M of sem is going to be set to 0. Why it is to set to 0? It is meaning that it is available for other processors. Any other process requesting the common shared memory can enter into critical section and execute it and set this semaphore value to 1. So finally it is to be cleared, so that in the next time whenever other process comes, that other process can execute the critical section. This is all about how processors are going to communicate, that is interprocessor communication, and how they are going to synchronize the messages by using mutual exclusion, semaphore, and critical section concepts. Hope you have understood this concept clearly. If you like the video, please share with your friends. Do like, share, and subscribe. Thank you.